Welcome back, class. Ngayon, ang gagawin naman natin ay we will be checking for base shear. So, let us analyze. View output file. And then, click natin tong soft story check. Okay, so maximize lang, palakihin lang natin yan. Ang gagawin natin ngayon ay we will be checking for vertical irregularities. So this is still part of the base shear check. So, isa sa kasama ng vertical irregularities yung soft story check. Okay? So, click mo yan. And then, ito siya. Based on ASE 7, ito sa first floor, wala siyang soft story. Ayan, tapos at second level, ayan, 4.7. Okay siya. Ibig sabihin, malakas siya sa x-axis tsaka sa z-axis. And then finally, sa third level, at 7.9 meters from the top of footing, okay pa rin siya. So, no soft story is detected. And then, another part of that is yung drift. So, drift is another check for vertical irregularities. So, una, dapat tama yung computation natin. So, ito yung seismic mass na tinatawag 4123.00. Seismic mass in the sense that it is the product of the superimposed dead loads plus self-weight. Okay, so kapag sinabing superimposed dead loads, yan yung finishing, tapos ceiling and utilities, tsaka yung 1 kPa na partition load. And then, kapag self-weight naman, yan yung volume nung properties na inilagay natin sa STAAD multiplied by the unit weight of concrete na pinasok din natin sa STAAD. Take note also na yung slab, meron din siyang self-weight, pero hindi siya nakapasok sa STAAD in the sense na dun natin siya iniload sa superimposed dead loads. So, ito yung seismic mass, and then i-compare natin ito doon sa post-processing. So, remember that this is 4123.00. So, pasok ko lang dito sa Excel, 4123.00. Okay, and then exit ko na ito. Pupunta na ako ngayon sa post-processing. Dito, i-click mo lang yan. And then, just click OK. Punta tayo dito sa reactions. And then, dito sa statics check result, ayan, click mo itong load case number 3 under FY. Okay? So, ayan siya. So, remember that load case 1, ito yung seismic. Ano? Tapos, load case 2 is also seismic. And then, load case 3, yan na yung dead load. 4 is the live load. So, ito tayo sa 3. And then, reaction is vertical. So, kunin natin yung FY, which is ito. So, if you will look closely, this is 4122.998. Okay, so, it is very close to yan, yung nandun sa output. So, that means, okay na yung computation ni STAAD. So, ibig sabihin, okay din ang ating loads. So, yan ang una kong i-check. And then next, i-off ko muna ito. Ayan. Tapos, kukumpitin natin ngayon yung base shear. So, yung 4123.00 sa earthquake engineering, sosolvin din natin ito mano-mano. Okay? At gagawin din natin itong mga base shear mano-mano. So, as a step ahead, ginawa natin sa STAAD, ito yung kanyang computation, seismic mass W. And then, blanco muna natin itong base shear P. And then, remember that these are my parameters. So, the zone, tapos importance factor, and then RW, X, and J, near source factors NA and V. Tapos, ito yung soil type, and then, ito yung CT, height of structure from the top of footing. And then, this is the seismic mass or the weight. And then, CV and CA. First, punta tayo sa structure period T. Sa basic physics, harmonics, waves, things like those, ang definition ng period is the time to complete one cycle. Okay? Vibration, meron ding period yan. From NSCP 208-12, ito yung kanyang equation. The period T is equal to CT times HN raised to the 3/4. Wherein CT is equal to 0.0853 for steel moment resisting frames. Take note of the word moment resisting frames. Ibig sabihin, hindi ito braced. Okay? Beams and columns lang. And then, CT is equal to 0.0731 for reinforced concrete moment resisting frames. Again, ito ay beams and columns lang. Wala siyang shear wall. And then, CT is equal to 0.0488 for all other buildings. Okay? And then, HN, that is the height of the structure. Yan yung pinakamataas na node sa STAAD or from the top of footing or from the support. So, in this demo, CT is equal to 0.0731 since the structure is concrete and HN is 11.1. So, we have here 0.444539 seconds, which is lesser than 0.70 second. Take note na ang allowable sa code ay hanggang 0.7 lang, less than 0.7. Okay? Kapag kapag 0.7 na siya or greater than, ang FT mo would be equal to 0. Okay? And then, that means you now have to compute 0.07 TV, which is equal to FT. Pero sa ating, in my experience, kadalasan ng buildings ko, ng projects ko, less than 0.70 seconds lang. Okay? Now, kailan nagiging greater than 0.70 itong structure period T? Siyempre, habang tumataas ang height mo, tumataas din ang period mo. Let's say, for example, ang HN natin. Take note na ang HN natin dito ay 2-story lang, no? And that is roughly like 3 meters per story multiplied by 2. Okay? Plus, let's say, yung depth of excavation 2 meters. Okay? So, tingnan mo, 8 meters lang. And then, for a 3-story building, yan. So, pasok yung 11.1 meters. So, 3 3 stories pala ito. Let's say, yung pinakamataas na na-design ko na building is 5 meters, ano? So, equal to 5 times 3 plus, let's say, 3 meters na excavation depth. Mataas na yan, ano? So, 18 meters. Yung period niya, 0.63 pa rin. So, it is less than 0.7. Okay, so habang tumataas, take note na magbabago yung period. So let's say 25. Yan. 25 meters or at 20 meters. Kasi pag 20 meters, ano na yan, mid-rise na siya. Okay? Mag-iiba na yung kanyang structure period. Malapit na siyang mag-iba. So what will happen aside from tataas yung kanyang period? Magpapalit ang iyong mga base shear. So let's say 25 meters. So ang value ng FT mo ngayon magkakaroon na. Okay? Which is equal to 0.07 times T times your base shear V. Okay? So, ibalik natin to sa dating height ng structure, which is 11.1. Okay, this is less than 0.7, therefore FT is equal to 0. And then, let's go to 208-8. This is the first equation for base shear. Ito siya. So, shear V is equal to CV times I times W all over RT. Note that in this equation, okay, yan, equation 208-8, shear ang kinukuha natin, yung V. Ang value ng CV mo, magagaling yan dito, 0.7168. Tapos yung I, yan yung importance factor. W, that's your seismic mass. R, you have 8.5. And then T, yan yung 0.44. Ngayon, kunin natin yung value ng CV. From table 208-8, kunin natin yung CV. Tapos, table 208-7 yung value ng CA. From this table, ang ating seismic zone is 0.4. So, dito tayo sa column na yan. And then, ang ating soil profile type is 4, which is also D. Okay? This is 1, 2, 3, 4. Kaya, ang kukunin natin na CV is 0.64 times NV. Okay? So that is equal to 0.64 times NV. Yan. Okay? Next, yung value ng CA from this table, 208-7, so Z is equal to 0.4 and then soil type D, 0.44 times NA. So, CA is equal to 0.44 times NA, which is equal to 1. So, that is simply 0.44. Now, we substitute this to our equation 208-8. Okay, so equal sign, CV, 0.7168 times I times the seismic mass 4123 divided by the quantity R times the structure period T. Okay? So that will give you 782.1369. Now, what if meron tayong hybrid na structure. Let's say, doon sa isang direction, RWX is moment resisting space frame lang siya. And then, pag sa RWZ, naglagay na tayo ng shear wall. Okay? So, ibig sabihin, magpapalit ngayon yung value ng RWZ kasi lalagyan natin siya ng shear wall. Tingnan natin ngayon ang value. Ito. Let's say, intermediate precast shear walls or braced frame. Sabihin natin 5, ano? Yan ang i-adapt natin sa RWZ. Or ilagay natin siya sa RWX and see what happens, okay? So gawin natin tong 5. Tingnan mo yung base shear. Yan. See? Ibig sabihin, at RWX, pinatibay mo yung structure mo in the sense na naglagay ka ng base shear, ay ng shear wall. Ibig sabihin, yung base shear ng building mo, yung capacity niya na mag-resist ng seismic forces ay tataas. Kaya, obviously, tumaas ito. Ano? Yan. So, balik natin sa 8.5, magiging 782. And then, in my experience, as much as possible, ginagawa kong parehas ang kanilang R value. Ibig sabihin, kung walang shear wall sa isang direction, dapat walang shear wall sa kabilang direction. Okay? Pero kapag super slender na yung structure mo or kailangan na ng mga bracing system or shear wall system, lagyan mo na sila in both directions. In short, kung gagawin mong 5 yan, gawin mo na ring 5 yung isa. Para hindi ka na mag-iisip pa kung ano ang pipiliin mong base shear, yung bang malaki o yung maliit. Okay? Things like that. Next, so from this, you have 782.14. Now let's go to equation 208-9. So 208-9 says the total design base shear need not exceed the following. So we have 1, 2, 3 equations. Okay, so 208-9 is this 2.5 CAIW all over R. So this is equal to 2.5 times CA na 0.44 times I na 1 times the weight all over your R value. Okay, so 533.5647. Okay, what does 208-9 says? It says the total design base shear need not exceed the following. So, hindi dapat siya lalampas dito sa first condition. Pero lumampas siya. Ibig sabihin, hindi mo to pwedeng gagamitin. Mamimili ka ngayon dito sa tatlo, di ba? Pipiliin mo ngayon yung maximum among these three conditions. Now, balik tayo rito sa ating R. Kung nilagyan mo yan ng shear wall 5, ibig sabihin lalaki masyado yung base shear mo. Kaya if in case na hybrid yung structure mo, may shear wall sa kabila, walang shear wall dun sa kabila. Ang iseset mo ngayon na yung R mo, pipiliin mo yung minimum dito sa dalawa or yung maximum sa dalawa. Okay? So, which is something like this. So, gagawin ko tong max. Yan. Okay? So this is maximum of these two R values and then enter. Yan. Okay, so 782.14. Ito yung pinili niya. Yan, see? So, pipiliin niya ngayon yung mas malaking value. Yan. Okay, guys, so yun ang if in case iba ang R value mo, piliin mo ngayon yung magproproduce ng maliit na base shear para safe ka. Then, let's go to equation 208-10. So that is 0.11 CAIW. So that is 0.11 times CA times I times the weight. Okay, so 199 and then finally 208-11 says shear is 0.8 Z NVI times W all over R. So lahat yan, conditions na yan, nanggagaling dito sa parameters. 0.8 times Z, ayan, 0.4 times NV times I times W divided by R. Okay, so 173.84. Next. So take note na yung ating design base shear 782.14 ay mas malaki dito sa 3 conditions na yan. Kaya, pipiliin mo ngayon yung pinakamalaki dito sa tatlo. Okay, so therefore, we will use 533.56. Okay? Ngayon, check din natin kung eto nga ba yung pinili ni STAAD. So, balik tayo dito kay STAAD sa post-processing. Dito sa utilities, sa analysis output. Punta tayo dun sa may soft story check. Ayun. See? So, yung seismic mass, yan, 4123. And then, yung 533.56. Yan yung pinili niyang base shear based on UBC 1997. Yan, UBC factor V. Okay, so that is 533.56, which is the same as this. Okay, so yan yung base shear natin, 533.56. Next is mag-check na tayo ngayon ng drift using the following load combinations. So, magbe-base tayo sa NSCP 203-5 tsaka 203-7. Yan ay galing dito, ano? Sa basic load combinations. Ayan. 203-5 and -7. 203-5 is 1.2 dead plus earthquake plus F1L. Ayan. So, apat na combinations yan. Dahil ang ating earthquake ay apat. Positive X, positive Z, negative X, negative Z. Okay? And then, ang ating F1 would be equal to 0.5 for other live loads. Gumamit ako ng 0.5 dahil ang live load ko ay ito 2.4 lang. Okay? Now what does the code says about your F1? F1 is 1 for floors in excess of 4.8. Okay? So 2.4 lang, kaya gagamit ako ng 0.5 na factor. Yan. So this is load case number 5. Take note na ang ating load cases is apat. Yung first two, yan yung EX tsaka EZ, tapos yung number 3, yan yung dead. Number 4, yan yung live. Kaya itong combination, load case number 5, that is actually combination na yan, ano? Then 6, 1.2 dead plus 0.5 L plus EZ. And then 7 naman, negative X. 8 would be negative Z. Tapos dito sa 203-7, magiging apat ulit yan kasi apat ang ating earthquake. So 0.9 dead plus earthquake plus 1.6 H. But wala tayong H, kaya dead and earthquake lang yan. Okay? So ito siya. Now let's go back to our STAAD. So dito tayo sa analytical modeling. Then punta tayo ngayon sa loading. Tapos dito sa load cases details. Ayan siya, yung first 4. Click tayo ng add. And then dito tayo sa define combinations. Then number 5 would be 1.2 dead plus 0.5 L plus EX. And then click natin si dead muna, factor na 1.2. Tapos susunod si live, factor niya ay 0.5. And then si EX, factor niya ay 1. And then you click add. Then let's close. Punta tayo ngayon sa utilities. Punta tayo sa command file. And dito natin gagawin yung the rest of the combinations. Okay? Which is eto. Yan. Loadcom 5. So, dito, yan yung ginawa natin kanina. So, merong technique ito, no? Yung number 3, yan yung load case number, wherein 3 happens to be your dead. Tapos yung live, yan yung 4. Tapos yung EX, yan yung 1. Now let me show ano ba yung mga load cases na yan. Ayan. Okay? Ito yung load cases. 1 is seismic, which is EX. Sorry. Ayan. 2 is seismic, which is EZ. 3 is dead. 4 is live. Okay, so remember that. balik tayo dito. So, gawin natin yan, ano? Next, gawin natin yung load combination number 6. So, I will copy this and change this to 6. Ang pinagkaiba ni 6 is yung huli magiging easy. Okay. So, first is the load number. Ang dead ay 3. The factor is 1.2. Tapos, live is 4. The factor is 0.5. Ang technique ko dito, kapag single number lang, yan yung load cases. Kapag may decimal place, yan yung factor. Okay? Tapos, laging mauuna yung load case or yung whole number. Finally, your easy, that is load case number 2, which is equal to 1.0. Okay? Take note na magkaparehas sila, yung dalawang yan. Okay? Ito, ang nagkaiba lang, yung earthquake mo, ito, EX, tapos number 2, naging easy. Next, we now go to load case number 7. Ito naman, naging EX siya, pero negative. Okay, so, I can copy this. Okay, then, palitan ko lang ito na 7, tapos palitan ko ito na negative. Okay, ayan, negative EX. Tapos, ganun din itong factor, negative. Tapos, ito, magiging 8. Tapos, yung easy, magiging negative. Which is, ito, negative. Next, gawin natin naman itong 0.9D plus EX. But before doing that, gawa tayo dito na comment. Let's take this as combinations for drift. Tapos this is 208 or 203-5. Okay? 203-5. Tapos sa next would be 9 to 12, 203-7. Yan. 203-7. And ang itsura niyan ganito. Ayan. Okay, so combinations for drift check 203-5 and then 203-7. So, save na natin siya. Then exit. Pag i-click mo yan, cases details, then, meron na yung ating combinations. Next is mag-a-assign na tayo ngayon ng drift parameters. By the way, drift also happens to be one of the serviceability checks. Dapat hindi masyadong malaki yung play ng building mo. Otherwise, mahihilo na yung mga occupants niya. From 208-21, ayan, determination of delta M, 208-21, the maximum inelastic response displacement, delta M, shall be computed as follows. Okay, so delta M is equal to 0.7 R times delta S. Alternatively, delta M may be computed by nonlinear time history analysis. Blah, blah, blah. Okay? So, 208-21, delta M, that is the maximum drift. Okay? Simply the maximum drift is equal to 0.7 R times delta S. Remember that our R is 8.5. Okay, tapos yung delta S naman, yan yung kukomputin ni STAAD. And then, meron ding conditions si NSCP if for structure period T. If our building is regular, meaning less than 0.7 seconds ang period niya, ang maximum drift natin ay 0.025 H or H all over 40. Ito ay makikita sa 208.651, which is this. Okay? Calculated story drift using delta M shall not exceed 0.025 times the story height for structures having a fundamental period of less than 0.7 seconds. If greater than 0.7, the story drift shall not exceed 0.02 times the story height. Ayan. Or, that is H all over 50. Now, remember that our computed T, period T, is 0.444 seconds. Yan. So, therefore, it is less than 0.7, kaya gagamitin natin si 208.6.5.1, which is H all over 40. Yan ang ating delta M. So, i-equate natin ang ating maximum drift kay H all over 40. Okay? Or that simply is maximum drift is equal to 0.7 times R times delta S is equal to H all over 40. Therefore, ang allowable drift natin ngayon si delta S, okay, is equal to H all over 40 divided by 0.7 times R. So, we will compute that. Ito, no? So, allowable drift is equal to 1 divided by 40 tapos divided by 0.7 times 8.5. It will give you 0.0042 times H. Okay? Yan, yon. Okay? Or that is simply equal to 1 all over 238. So, eto ngayon ang ipapasok natin kay STAAD. And take note that this is dependent on our structure period T. Hindi siya dependent sa H, dependent siya sa structure period T. Okay, kunin natin ngayon yung decimal place nito. So that is 0.004217. Okay? So punta tayo ngayon kay STAAD. Punta tayo kay Analysis and Design dito. And then Analysis and Design, i-click natin si Load List. Tapos select natin si 5 to 12. Yan yung ginawa nating combinations, ano? So 5 hanggang 12, tapos click po si arrow right. Then you press OK. Tapos dito ngayon, i-click mo si Load List. Ayan. Okay? Tapos, i-click mo si Post Analysis command. Ito siya, no? And then, yan ang lalabas. And then, i-click mo si Define Commands dito. Tapos, you click or you check after current, ito. Tapos, piliin natin ngayon si story drift. Ito, yun. Papasok mo dito ngayon yung value ng 0.004217, then add, click add, and then close. Okay? Ngayon, i-check natin sa utilities dito sa command file kung ano ang nangyari. So, kung nahirapan ka dito sa commands, pwede mo nang idiretso yan sa editor. Ganito lang yung nangyari, no? So, perform analysis. Okay, load list 1 to 4 and then print story drift. Oops, mali ito. Palitan natin yan. Gawin nating load list 5 to 12. Okay, so laging mauna yung load list before the story drift. Then let's save and then let's analyze. Run analysis. Then view output file. Balik tayo dito sa story drift. Ayan. Double click mo lang yan. Tapos check mo siya. At level 1.5, take note, ito yung ating beam sa ground level. Ito yung top of footing. So, ibig sabihin, top of footing mas mababa ng 1.5 meters from NGL. See? Sa 1F beams pa lang, fail na tayo sa story drift. Okay? And then, at the second story, 4.7 meters above the top of footing, fail pa rin siya. And finally, dito sa third floor, fail ulit siya sa story drift. Okay? So, ito ang aayusin natin. Remember na ang ating first check, yung vertical irregularity, is yung soft story. Pasado siya. Tapos, sumunod naman, next na check is story drift. Fail siya. Dito. So, bago tayo magde-design ng beams and columns, dapat pumasa muna siya sa soft story tsaka story drift. Ito ngayon ang gagawin natin. Paano? Mag-i-increase tayo ngayon ng mga sizes ng beams and columns. Ngayon, pag hindi pa rin pumasa sa story drift, and then that's the time na sasabihin mo na sa architect mo na, sir, magdadagdag tayo ng extra column sa gitna. Things like those. O kaya, ma'am, maglalagay po tayo ng pundasyon sa gitna para pumasa yung ating building sa story drift. Yan. So, in short, hindi lahat architect ang masusunod. Next is, kukunin natin yung center of rigidity. Take note that this center of rigidity is based on your rigid diaphragm. So, i-exit ko na ito. Dito tayo ngayon sa analysis. Dito, no? You click print soft story drift. Yan. Okay? Tapos, click define commands here. And then, i-check after current. Tapos, i-click mo si Okay, ulitin ko. Let us click print soft story drift. Tapos, i-click natin si post analysis commands. Ayan, ito pala yun. And then, you click define commands. Sorry. Click mo ulit si print story drift. Pero nandito na tayo sa post analysis. Then, you click define commands. Diyan nalalabas ngayon yung diaphragm center of rigidity. And then, you click i-check after current. After that, diaphragm center of rigidity, tapos add, and then close. After that, check natin kung anong nangyari sa editor, and then we will run. Ayan siya. So, nadagdagan lang, ano? Perform analysis, load list 5 to 12. Yan yung drift combinations. Tapos, print story drift. Yan yung pass, fail. And then, print diaphragm center of rigidity, and then finish. Okay. So, yan, ganyan lang kasimple dito sa editor. Now, let us analyze. Then, let's look at the output file. Click natin tong diaphragm center of rigidity. Double click mo lang yan. So, eto siya. Ibig sabihin at level 1, that is the first floor beams. Ang coordinate ng diaphragm, ayan, 6.75 and then 5.5. Level 2, parehas lang. Level 3, parehas lang. So, basically, parang ang ating structure ay somewhat regular. Next. So, we will exit this. Take note na sa ating output, pasado na tayo sa soft story. So, mag-e-edit na tayo ngayon ng ating properties para pumasa sa drift. The first thing that we will do is to increase the first floor column and first floor beam sizes, then check for drift. Okay? So, ayan, ating first revision. So, punta tayo ngayon sa properties. Ang first floor column, kung hindi mo na alam, i-click mo na yan isa-isa. Hanapin mo ngayon si first floor columns. Ayan. So, this is third floor, second floor, first floor columns. Siyempre, that also includes your footing columns. So, magiging 430 by 430 yan. So, double click ko lang yan, magiging 0.43 by 0.43. So, basically, in-increase ko lang siya. Then, change. Siyempre, ganun din sa footing columns. 0.43 by 0.43 and then change. Tapos, etong 1F beams. Ayan. So, double click ko rin yan. Then, papalitan ko siya ng 0.48 by 0.35. Ngayon, walang pattern kung anong size ang ipapalit mo. Bahala ka na. Okay? So, in my case, hindi malaki ang aking revision. Siyempre, magastos kung malaki kagad. So I will now click change and then close. Tapos analyze ulit. Dapat pasado na, mayroong papasa sa diaphragm, sa soft story, and then sa drift. Okay? So okay siya sa soft story. Check natin yung drift. Ayun. At level 2 sa first floor beams, meron ng mga pumasa, pero meron pa ring dalawang fail. So next is i-increase ulit natin. But now let's change pin to fix and see the effects. Okay? Meron lang akong ipapakita rito. So sa utilities, papalitan natin yung supports. Remember, papalitan natin yung supports from pin to fixed. Sa command file, dito na ako magpapalit. Ayan, 1 to 12. Change this to fixed. Then analyze, pakita ko lang yung effect. Sa drift. Okay? So, story drift. See what happens. Pass, pass, pass. Ayan, see? Ang laki ng pinagbago kapag pinalitan mo yung support mo from pinned to fixed. Ibig sabihin, nagre-resist na ngayon yung footing rebars mo ng moment. Yan. Pero, ide-design mo yung footing mo na may moment bars. Okay? So, for now, ibabalik ko ulit si support sa pin. Dahil yun ang goal natin. Our structure is pinned. So, balik ako dito sa utilities. I will change it back to fixed. Change it back to pinned. Yan. So, alam na natin na kapag pinalitan natin yung supports natin ng fixed, malaki ang naitutulong nito sa drift. Now, my second revision would be to increase the second floor beams and then the second floor columns. Take note na may mga pumasa na sa first floor level. So, patitigasin natin ngayon yung second floor beams and columns. So, sa properties, change natin si second floor beams. Ayan siya. Gawin natin siyang 0.45 by 0.35. Change. Tapos, si second floor columns. Ayan. Change this to 0.4 by 0.4. Then, analyze again. And then, check for drift again. Yan, see? Pumasa na ngayon yung ating first floor level. Pass na siya lahat. Tapos, sa second level, 4.7 to 7.9, meron na ring, marami na ring pass, pero meron pa ring isang fail. Ngayon, yung nag-fail na yan is load combination 6. Now, let's look at load combination 6. Dito tayo sa analytical modeling. Tapos dito sa loading, load cases details, number 6, ayan siya, 1.2 dead plus 0.5 L plus earthquake Z direction. And ang Z direction, paganyan. Next, dito na tayo ngayon sa third revision. So, balik properties. Palitan natin na si third floor beam. Ayan. And palitan ko siya ng 0.4 by 0.35. Ang ginagawa ko, okay, I just make sure na yung size ng columns ko ay mas malaki pa rin sa beams. Okay? For example, ito, this is 35 ang width. Ngayon, yung supporting column niya is 40. So, pasok pa rin. How about this? The width is also 35, but the column is 40. Kaya, safe pa rin siya. So, I will analyze again. And then, check for drift. Pass. Okay. So, lahat, pass na siya sa drift. Then, check mo rin yung soft story. Since nagpalit tayo ng mga sections, always check if it is okay with soft story. So far, okay na siya. Next. The next step here is to design now our beams and columns. Design in the sense na check na natin ngayon yung safety ng beams. Dito na papasok yung reinforced concrete design. Okay? Kapag sa beams, dapat yung AS mo, kaya niyang i-resist yung maximum moment MU in 6 station checks. 2 sa support, 2 sa other support, and then top bar, bottom bar ng midspan. So, things like that. Sa column naman, kailangan pasado rin siya sa maximum moment tsaka axial load. Okay? Sa RC, kailangan mag-produce tayo ng interaction curve. Okay? With axial load, meron siyang corresponding na moment. Ngayon, ang gagawin ni STAAD, hahanapin niya yung pinakamalaking AS based on your axial loads tsaka moments. Okay? So, yun ang importante. Hahanapin niya yung pinakamalaking AS. So, that ends part 2 of our STAAD. Now, let me run through the editor. So, balik tayo sa utilities, dito sa command file. Ang nangyari, nakagawa tayo ng drift. Okay, tapos una pala na-check natin siya sa soft story, and then na-i-adjust natin yung mga sections para pumasa sa drift, and then nakagawa tayo ng mga combinations. Okay, so ito lang yun. Now, part 3 is reinforced concrete design. So, thank you guys for listening.